Number 11, use implicit differentiation to find an equation of the tangent line to the curve at the given point. So, noticing on the left-hand side, we have y times the sine of 5x. That's going to require the product rule. On the other side, x times cosine of 5y will also require the product rule. And just as a reminder, when you're doing implicit differentiation, anytime you differentiate a y variable, you have to attach a y prime. Here we go. First, the derivative of the first. The derivative of y is 1. But since it's a y, we have to attach a y prime. We have the derivative of the first times the second plus the first times the derivative of the second. And since the angle is not just x, we will have to use the chain rule. So the derivative of sine is cosine. The stuff inside stays the same, multiplied by the derivative of the angle, which is 5. On the other side, the derivative of x is 1 times the second plus the first times the derivative of the second. Again, this is going to require the chain rule. So the derivative of cosine is negative sine. The stuff inside stays the same. And then when we differentiate the angle, since it has a y, we're going to have to attach a y prime. And so that is the first step using implicit differentiation. The next step, we can go ahead and evaluate for x and y, and then simplify. Alright, so that'll give us y prime times sine of 5 times x, where x is pi over 5, plus y, we have a y, that is pi over 10, times the cosine of 5 times x times 5, and then on the other side, 1 times anything is itself, so that'll be cosine of 5 times y plus x. We have an x by itself times negative sine of 5 times y times 5y prime. And then we can simplify. 5's reduce out, gives us the sine of pi. Here, 5's reduce out, gives us the cosine of pi. 5 goes into 10 2 times, giving us cosine of pi over 2. And 5 goes into 10 2 times, giving us negative sine of pi over 2. Next, if we scroll up some, we're going to simplify. Sine of pi is 0, and that will effectively eliminate that term. Plus pi over 10 times the cosine of pi. Cosine of pi is negative 1, and then don't forget we have that times 5. On the other side, we have the cosine of pi over 2, that is 0, plus we have pi over 5 times. Now, sine of pi over 2 is 1, and then that negative will make that negative 1 times 5y prime. Alright, next step. 5 goes into 10 2 times, giving us negative pi over 2. On the other side, these 5's cancel, giving us negative pi times y prime. If we divide both sides by negative pi, to isolate the y prime, we're going to get that that is positive half. Now that is also the slope of our tangent. And now we can use the point slope form to get the equation of the tangent line. Here we go. Y minus y1. Remember the y was pi over 10 equals m, which is a half, x minus pi over 5. And then if we simplify that equation, doing the distributive property and bringing the minus pi over 10 over, that's going to give us 1/2 x minus pi over 10 plus pi over 10. Those will effectively eliminate each other and give us y equals 1/2 x for our simplified final answer. Next, number 12, we simply need to find the indicated derivative. Here we're looking for f prime of 3. And so the first thing we need to find is f prime of x. The derivative of x cubed is 3x squared using the power rule. The derivative of e to the x is itself, since the exponent is just x. And the derivative of a constant is 0. And now we can evaluate at 3, giving us 3 times 3 squared minus e to the third. 3 squared is 9 times 3, that's 27 minus e to the third, and that would be our exact answer. 27 minus e cubed. Next, number 13, we need to find the derivative, evaluated at a half, and we have multiple of x's. We've got x cubed times e to the 2x. That's going to require the product rule. So we're going to take the derivative of the first times the second plus the first times the derivative of the second. Now the derivative of e to the 2x is itself, and since the exponent is not just x, we will have to apply the chain rule. So multiplying that times the derivative of the exponent gives us a 2. That is the derivative. Now we can evaluate that at a half. So that's going to give us 3 times 1/2 squared times e to the 2 times a half plus 1/2 cubed times e to the 2 times a half times 2. And that'll simplify. 1/2 squared is a fourth. A fourth times 3 is 3/4. E to the half of 2 is 1, and you don't really need to write the 1. Plus, over here we have half cubed. 1/2 to the third is 1/8, but an 1/8 times 2 basically will eliminate one of those factors of 2 and put that down to a fourth. E to the half of 2 is 1 again, and then notice that these are like terms. 3/4 e plus 1/4 e is 4/4 e, or just e. And so that answer is simply e. Next, number 14, we need to find the derivative evaluated at 2. The derivative of 1 over x, what we should do first is we should rewrite that as x to the negative 1 times natural log of 3x, and that'll make it a lot easier to take the derivative using the power rule. So now we can say the derivative of x to the negative 1 is negative 1 x to the negative 2 minus the derivative of natural log is 1 over x, but that's if the thing you're taking the natural log of is just x. So since this is 3x, that's going to be 1 over 3x multiplied by the derivative of the stuff inside using the chain rule. And then these 3's will reduce out, and we can now evaluate at 2. I'm going to put this back into fraction form. So that'll be 1 over x squared, but x is 2. minus 1 over x, again x is 2, which will give us negative 1/4 minus a half, or negative 3/4. Next, number 15, we need to find the derivative and evaluate at negative 2. And the derivative of inverse tangent is 1 over 1 plus x squared. But since our angle is not just x, we're going to have to apply the chain rule. Again, the derivative of inverse tangent is 1 over 1 plus whatever the angle is squared. Here the angle is x squared, which is going to be squared. And then you do need to multiply by the derivative of the angle, which is 2x. And that will simplify to 2x over 1 plus x to the 4th. And then we can evaluate that at negative 2, giving us 2 times negative 2 divided by 1 plus negative 2 to the 4th, negative 4 over 1, that's going to be plus, a negative number to an even power becomes positive, and that's going to be 16. So our final answer in simplest form, negative 4 over 17. Negative 4 over 17, and we're done. Next, number 16. Look, we need to simply find the derivative. We don't have to evaluate this time. But I see that my function is not only a rational function, but it involves a trig function. So what I'm going to do, since I don't really like to do the quotient rule or have to take the derivative of secant, I'm going to see if I can simplify this. Here we go. I happen to know a trig identity that says that secant is the same as 1 over cosine x. And then I can apply the keep, change, flip. So that'll give me x squared over 1 multiplied by the reciprocal of this fraction, cosine x over 1, which gives me my new function to be x squared times cosine x. And then I can apply the product rule. To take the derivative, we're going to do the derivative of the first times the second plus the first times the derivative of the second. And the derivative of cosine is negative sine x. And that will simplify to 2x cosine x minus x squared sine x, and that is our final answer. Next, number 17, we need the second derivative. So to take the first derivative, notice that we have two functions in terms of x multiplied. We're going to have to use the product rule. The derivative of the first times the second plus the first times the derivative of the second. And that was pretty straightforward, but remember we need the second derivative, and so then we get to repeat the process. However, now we have two terms, and the second term is going to require the product rule again. So, for the first term, the derivative of sine is cosine. That's going to leave us just 3 cosine of x plus, and then the product rule. The derivative of the first times the second plus the first times the derivative of the second. And the derivative of cosine is negative sine x. And then if I simplify, notice that I do have like terms. So 3 cosine x plus 3 cosine x, that's going to give me 6 cosine x. And then this last term is going to be minus, we have a negative times a positive, giving us minus 3x sine x. And that is the final answer in simplest form. Next problem, number 18. We need to find the derivative of g of t. Here we notice that we do have the product of two functions in terms of t, so we're going to have to apply the product rule again. And what I'm going to do to start with is I'm going to rewrite this radical expression in terms of a rational exponent, and that'll make it a lot easier to take the derivative of that factor using the power rule. Alright, so here we go. The derivative of g of t says we're going to take the derivative of the first. 1/3 times 3 is 1. T to the 1/3 minus 1 is negative 2/3. That's the derivative of the first times the second, plus the first, 3t to the 1/3, times the derivative of the second. Now the derivative of natural log of t is just 1 over t, and since it's not just t, it's 9t, we're going to have to apply the chain rule, multiplying by the derivative of the stuff inside. And then a couple of steps of simplification are in order. Making this negative exponent positive means we're going to put it in the bottom. That's going to be 1 over t to the 2/3 times natural log of 9t, plus, I'm going to put this back into radical form, 3 cube root of t, and these 9's will cancel, multiplied by 1 over t. So, g prime of t, if I simplify again, we can see that this natural log of 9t, I can put it over 1, and then multiply those into a single fraction, giving us natural log of 9t all over, and if I put this back into radical form, that'll be cube root of t squared, plus, notice on this second term, I think I may have prematurely put this back into radical form. If I go ahead and rewrite that as t to the 1/3, I can see that I do have t's top and bottom, and I can reduce those. So this t has a 1 for an exponent. If I minus the 1/3 to get rid of the t in the top, that's going to give me 3 over t to the 2/3, or the cube root of t squared, and then I can see that I have a common denominator. So my final answer for g prime of t in simplest form is going to be the natural log of 9t plus 3 all over the common denominator of cube root of t squared. Next, number 19. Here we need to find the derivative. We have the inverse sine of x squared with a coefficient of 7. We know that the derivative of inverse sine is 1 over the square root of 1 minus x squared. So this coefficient is just going to hang out front. We're going to have our derivative of 1 over square root of 1 minus x squared. But here our angle is x squared, so that's going to be squared. And since it's not just x for the angle, we are going to have to use the chain rule. So we will need to multiply by the stuff inside, which is 2x. And then that will simplify. The 7 and the 2x, those are both in the numerator, giving us a numerator of 14x all over the square root of 1 minus x to the 4th. And that is the simplest form of the derivative of this function. Next, number 20. A man climbs to the top of a 6-meter ladder that is leaning against a wall. The bottom of the ladder begins to slide away from the wall at a rate of 1 meter per second. How fast is the man approaching the ground when the ladder makes a 20-degree angle with the ground? So let's sketch a picture of this end result and see what's going on. Alright, so here we have our picture with our man at the top of the ladder, and the ladder on its way down makes an angle of 20 degrees with the ground. I'm going to label this side X and this side Y, representing the X coordinate, or the X axis and the Y axis. And what they give us here when it says that the ladder begins to slide away from the wall at a rate of 1 meter per second, that's the rate of change of X, which is the derivative of X, or the X prime. That is 1 meter per second. We want to know how fast the man is approaching the ground. That is, how fast is this Y side changing, and that is Y prime. That's what we're looking for. And we have a formula that relates all three sides of a triangle, and we have a formula that relates all three sides of a right triangle, the Pythagorean theorem, and that's the equation we're going to start with. So x squared plus y squared equals, I'm going to say L squared. L represents the length of the ladder, or the hypotenuse. And then I'm going to differentiate that equation. So we have the derivative of x squared, which is 2x, times the rate of change of the x, plus the derivative of y squared times the rate of change of the y, and the derivative of L squared multiplied by the rate of change of L. And then we're going to plug in for the pieces we know. We know that x prime, the rate of change of that side, is 1, and so that will simplify to just 2x. 2y, y prime, I don't know any of those values yet. And the rate of change of the ladder. The ladder doesn't change length as it slides down the wall. It continues to be a 6 meter long ladder. So that rate of change is 0, making this entire side go to 0. And then what we can do is we can isolate the variable that we're trying to solve for, and then see if we can find the remaining pieces. Okay, next, moving the 2x to the other side is going to give us 2y, y prime equals a negative 2x. And then if I divide both sides by 2y to isolate the y prime, that's going to reduce to just negative x over y. And so if I simply knew the length of the sides x and y at this point, I could find the rate of change of the y side, which is the speed at which the man is approaching the ground. So here we go. Using our trigonometric identities, we know that sine theta is, here my theta is 20, sine theta is y over r. But my r is the length of the ladder. And so then what I can do is multiply both sides by 6, and I'll know the value of y. And so we can see that y is whatever 6 sine 20 is. I'm actually going to leave that 6 sine 20 to leave it exact. Okay? We also know that cosine of theta, cosine of our angle, is x over r. Again, if I multiply both sides by 6, then I'll know what x is. Here x is 6 cosine of 20. And now that I know x and y, I can come over here and plug in. So x is 6 cosine of 20. Y is 6 sine of 20. Our 6's will cancel. We know that cosine over sine is cotangent. And so, since that's not going to be a nice number, that would actually be the exact value. But I do want to go ahead and approximate that, say, to the nearest 10th, 100th. It doesn't specify in the problem where they want us to round to, but we can approximate that value. And to do that, I'm going to use my calculator and input this cosine 20 over sine 20 and make that a negative. All right, here we go with our class whiz. In degree mode, we're going to say negative fraction. We have cosine of 20 divided by sine of 20. And rounded, that's going to be negative 2.75. And again, the units here would be meters per second. And it is negative because that length is decreasing. The man is moving in a downward direction, but his rate of change is negative 2.75 meters per second.